Hi, this is Unit 9, Lesson 1. So Lesson 1 and Lesson 2 are done together. There's a separate video for Lesson 2. So I'm just going to do the first half of it talking about imaginary numbers, and then Lesson 2 talks about complex numbers. So the square root of 25, as you guys all know, or you should know, is equal to 5. And that's because 5 times 5 is 25. Now when I put a negative in front of it, the square root of 25 is negative 5. Because actually when I do the square root of 25, there's two answers, positive 5 and negative 5. So if I just write square root of 25, I generally just want the positive answer, but if I put a negative in front of it, I'm looking for the negative answer. Okay, and that again is because negative 5 times negative 5 is 25. Now when I do the square root of negative 25, there is no answer. That's because there's no number that exists that I can multiply it by itself and get negative 25. There's no number, all right? So we now are going to introduce to you imaginary numbers, and that will help us deal with negatives under the radical sign. So I use an I for an imaginary number. It is a button on your calculator. It's down towards the bottom by that decimal. All right, and an imaginary number I is when I have a negative number under a radical. Now I do need you guys to add this to me. The radical was not put in, so in your notes, I equals the square root of negative 1. So you guys have to add that radical. And basically the rule is you can never leave a negative under a radical. All right, it's not simplified if there's a negative under the radical. So let me show you how I deal with this. So exercise 1, square root of negative 4. Basically, I'm going to make it equal to the square root of square root of 4 times the square root of negative 1. Square root of 4 is 2, and the square root of negative 1 is I, because I just learned that up here. Square root of negative 1 equals I. So that's my answer, 2I. Square root of negative 9. Well, square root of 9 times square root of negative 1. Square root of 9 is 3, and the square root of negative 1 is I. So those are pretty easy because those are perfect squares. What happens if I don't have a perfect square, like question 3? So I'm going to break this down to the square root of 8 times the square root of negative 1, just like before. But the square root of 8 can be simplified. Remember, I say what times what is 8, and one of the numbers needs to be a perfect square. Well, 4 times 2 is 8. Now the square root of 4 is 2. The square root of negative 1 is I, and the square root of 2 will stay square root of 2. Let's try another one, similar also. Square root of negative 24. Well, it's the square root of 24 times the square root of negative 1. The 24, though, can be simplified. 4 times 6 is 24. The square root of 4 is 2. Square root of negative 1 is I, and the square root of 6 stays square root of 6. And let me just show you what happens if there's a number in front. Basically, the number in front just stays in front. I'm going to simplify the 48 to 48 times negative 1. Now the 48 can get simplified. There's a perfect square that goes into 48. 16 times 3 is 48. Now the 16 is equal to 4, so that gets multiplied by the negative 2 that's in front. The square root of negative 1 is I, and the square root of 3 stays square root of 3. So that simplifies to this radical 16, and the radical negative 1 simplifies to 4I, and that 4I gets multiplied by the negative 2 in front. So it's negative 8I radical 3. Okay? Let's solve some quadratics. So whenever I'm solving, I want to get x by itself. So I'm going to get rid of the 8 by subtracting 8. All right, and I have 5x squared equals negative 20. Again, I'm trying to get x by itself, so I'm going to divide by 5 to get rid of that 5. Negative 20 divided by 5 is negative 4. Now to solve for x, to get x by itself, I have to take the square root of negative 4. Well, the square root and the square cancel out. And then the square root of negative 4, we just did that up above, is 2I. Now the only thing I'm going to need you to add is there's actually two answers, so I'm going to add a plus and minus 2I. All right, let's try another one that has a fraction in front of it, but you're really just doing the same thing. I'm trying to get x by itself, so I'm going to get rid of the 20 by subtracting it. Now, when I have a fraction, the easiest way to get rid of that fraction is probably to multiply it by the reciprocal. Because when I multiply it by the reciprocal, the 2's and the 1's cancel. But whatever I do to one side, I have to do to the other side. So I also have to multiply the other side by 2. So x squared equals negative 18 times 2 is negative 36. And again, I'm trying to get x by itself, so to get rid of the square, I take the square root, and x equals plus or minus negative 6. So the last thing that we're going to talk about is powers of I. All right, now you can do this in your calculator. This first row right here could all be done in your calculator. I to the first power is I. Well, you should know that anything to the first power is just itself. In your calculator, I to the second power is negative 1. Now the I button, remember, is down by that decimal, so you hit second, I, and then you hit the squared button. I to the third power is equal to negative I. Again, I'm doing this in my calculator. And I to the fourth power is equal to 1. Now, these answers that I just got, I, negative 1, negative I, and 1, actually keep repeating. There's only 4 possibilities of answers when I have exponents with I. So let me show you why they keep repeating. The key is that I to the fourth equals 1. All right, so I to the fifth, I'm going to simplify it right here. I'm going to make it I to the fourth and I to the first. Now the reason I do that is because I to the fourth equals 1, and then this is just 1 times I, which is I. I to the sixth, I'm going to break it down to I to the fourth, because I know that equals 1, and I squared. Well, I to the fourth, really just ignore that, and I'm evaluating I squared, which I already did up here, and that equals negative 1. I to the seventh, I'm going to break down to I to the third, I to the fourth, because that equals 1, times I to the third. Basically, ignore the I to the fourth. I know it equals 1. I to the third equals negative I. So see how these just keep repeating. And I to the eighth is really just I to the fourth times I to the fourth, and each of those is 1. So this pattern just keeps on going on and on and on. If you have a newer calculator, you can actually do any exponent of I. If you have an older calculator, you can't. So you're going to have to simplify just like I'm simplifying here. So these powers of I are important to know. You don't have to memorize them. You can always do them. I to the 0 power is 1, because anything to the 0 power is 1. I to the first power is I to the second power is negative 1. I to the third power is negative I. We already talked about this on the other page. And I do want you to add one more. I to the fourth power is 1. That's the important one. In fact, any exponent that is a factor of 4 is going to equal 1. Like I to the 8th is 1. I to the 12th is 1. I to the 16th is 1. Because remember, this pattern just keeps on going on and on. I to the 20th is 1. I to the 24th is 1. I to the 28th is 1. All right, so I'm going to use this concept right here that any exponent of I that's a factor of 4 will equal 1. So when I'm trying to do like I to the 38th, I'm going to break it down to I to the 36th and I to the second. Why did I decide on that? I can't simplify I to the 38. It's not a factor of 4. But I want the biggest number, as close to 38 as I can get, that is a factor of 4. And that's going to be I to the 36. Now basically ignore it, because we know that any I with an exponent that's a factor of 4 just equals 1. And then all I need to know is what I squared is, and I have that up above. It equals negative 1. So this just equals negative 1. Done. I to the 21st, it's not a factor of 4. So you break it down to the biggest number as close to 21 as you can get that is a factor of 4. And that's going to be I to the 20th. Ignore that because we know it equals 1. And all I'm doing is I to the first power, which equals I. So you only have to know the first four, and you can do any exponent that you want. I to the 83. Again, I want it to be a factor of 4, so I want the biggest number as close to 83 as possible that I can get that's a factor of 4. Well, that's I to the 80th. What's left over? 3. We can ignore the I to the 80th because I know that it's equal to 1 because it's a factor of 4. And then I to the third is just negative I. All right, and last one, I to the 40th is a factor of 4, so that just equals 1. Last problem here. If you have a newer calculator, you can do this right in your calculator. If you don't have a new calculator, you can't do it in your calculator. So I'm going to do it out. 5 is just hanging out, 5. I to the 16th is a factor of 4. It equals 1. Okay, that first part's pretty easy. 3 is hanging out. I to the 23rd is not a factor of 4. So I'm going to break it down to I to the 20th and I to the 3rd. Now you guys know that I to the 20th is equal to 1 because it's a factor of 4. I to the 3rd is equal to negative I. So this is just 3 times negative I, which is negative 3I. And then 5 times 1, the first term is just 5. Now I still have to do the I to the 26th. I break it down to the biggest number I can. That's a factor of 4. That's going to be 24 and 2. I to the 24th is equal to 1, and I squared is negative 1. So now at this point, the 5 and the negative 1 are real numbers. Those can be combined together, and then the negative 3i gets added on. This is called a complex number, and the other video will talk about complex numbers.